Hello and welcome to video 3 of the Introduction to Jamovi. In this final video, we're going to discuss how to run a correlation, create a scatter plot, run a simple ordinary least squares regression or OLS linear regression, run a multiple OLS regression, and then export the tables and figures out of Jamovi into Word or into PDF. So let's go back into Jamovi. We left off with running the one-way ANOVA. And what I'm going to do now is I'm going to go ahead and then click on regression. And before we continue, so when we have questions about the relationship of two continuous variables, we're going to try to determine the relationship between GDPPC and perceived corruption, leaving corruption in its original scale from 0 to 10, but reverse coded. The most basic graph for two continuous variables is a scatter plot. The scatter plot shows us the two variables appear to be related. We will follow this visual inspection up with two tests. First, a correlation tells us how tight the relationship is between the two variables. A correlation close to 0 means that there is no relationship. A correlation close to 1 is a perfect positive correlation. A negative 1 is a perfect negative relationship. And that tells us how close it is to a perfect straight line. Second, we're going to go ahead and do a regression, which tells us the nature of that line in question. The line is defined by the slope and the intercept, so it's rise over run. And the regression output will tell us if either of those coefficients are statistically significantly different than a coefficient of 0. So to start, we're going to go ahead and click on Analysis, Regression, and I'm going to go ahead and click on Correlation Matrix. From here, I'm going to take our corruption 2, move that into our variable box. Now I'll go ahead and take GDPPC and move that there too. We're going to leave this as a Pearson correlation coefficient. Pearson is used when there's two quantitative or continuous measures. We're going to go ahead and ask for flag significant correlations. I want the n and the constant intervals. And then I'm also going to ask for a plot. So within this correlational matrix, it's a measure of association, and the sign indicates inverse versus direct proportional relationship. So a 0 is no relationship, a value 1 is a perfect positive relationship, a negative 1 is a perfect inverse relationship or a negative relationship. This is going to be a 2x2 table, but only one cell is relevant. The diagonal, corruption 2 with corruption 2, and GDPPC with GDPPC, that's hyphened out because it's essentially 1. Looking at this, our Pearson's R, that's our correlation coefficient, is a strong and negative relationship. So as countries get more and more corrupt, their economy gets lower and lower and lower. So it's a negative relationship. Because this is cross-sectional data, we cannot assume causality though. And based on that, that relationship is statistically significantly different than a relationship of 0. If we scroll down a little bit, this is our plot. So we have our regression line, our 95% constant intervals, that gray part, and all of our dots. You can also go ahead and click on statistics. And that's going to go ahead and superimpose the correlation coefficient. And if you do densities, that's going to go ahead and superimpose histograms for corruption 2 and GDPPC. Now we do see a little bit of potentially a floor effect here too, so something to consider. So I'm going to go ahead and click on this to finish that. And now we're actually going to run a regression. So the regression provides additional information about the relationship of these variables. Specifically, it allows you to guess or predict the value of one variable given the information from another or multiple other variables. For this, we're going to regress GDPPC, our dependent variable, over corruption 2, which is our independent variable. To do this, we're going to click on the Analysis tab, click on Regression. We're going to click on Linear Regression. We're going to go ahead and move GDPPC to our dependent. And because corruption 2 is a scale here, or it's essentially a continuous variable, we want to put it in the correct box here. So if you have any variables that are continuous, they're going to go here. If anything's like a factor or a grouping variable, like we have whether or not they're an OECD member, that would go into here. So what I'm going to do then is we're going to go ahead and move corruption 2 to a covariate. And that's going to go ahead and give us our basic regression. We're going to add some more features to this though. So in the assumption checks, I'm going to ask for collinearity there as well, QQ plot and the residuals. So looking at this, we have a potential outlier here. If we do Cook's distance, yeah, this is probably an outlier. So we'd probably want to find this case and run the regression both with and without it to see how that can impact the model fit and the coefficients. So under model fit, we're going to ask for the omnibus F test. That's your overall significance test for your overall regression. Under model coefficients, get the ANOVA test, and I also want standardized estimates, constant intervals, and that looks great. So what I'm going to do is I'm going to scroll all the way up, and now we have our table. So do we have anything? Our overall omnibus test. So we have, looking at our R and R squared, this is essentially because we have one predictor, one dependent variable, one outcome variable. Our correlation coefficient in our R is the same. When you have multiple predictors, that's going to change though, because you have multicollinearity potentially. Based on the R squared, we were able to account for the 80% of the variability in GDPPC by including corruption 2 into our model. That overall test is statistically significant. This information here is the same here. This just also gives us the sums of squares. So the important part is to look at the model coefficients. So knowing nothing about a country's corruption score, our best guess, our predicted value is 39,391. For each unit increase in corruption, so going from a 4 to a 5, 5 to a 6, and so forth, there's a reduction in 4,761 units of GDPPC. Both of these are statistically significant. And if we look at our standard estimate, this is for each standard deviation increase in corruption 2, there is a 0.89 standard deviation decrease in GDPPC. So we have our multicollinearity, but since we only have one variable, it's not going to be a problem. So we could essentially write this equation as GDPPC predicted equals B0, which is our intercept. So 39,391 plus negative 4,761 times corruption 2. For each value increase, that's going to go up, and then there's going to be a little bit of error too. If we wanted to add an additional variable, we can go ahead and move literacy into a covariate, and we can see how that model changes. So we have a reduction in R squared, and we probably also would want to, let me scroll down to model fit to get adjusted R squared now, because as we include more predictors in our model, that's an increased bias, so we want to account for that when for the variance accounted for statistic, which is our adjusted R squared. Our overall model is statistically significant. We can also look at our coefficients. Our intercept is much lower than that 39,000 beforehand, and also for each increase in corruption, there's still a decline, but it's not as large when we include another predictor. And also interesting is as we increase literacy, for each increase in literacy, there's an increase in 95.7 points on the GDPPC metric, or 0.26 standard deviations for each standard deviation increase in literacy. So we have pretty low VIF intolerance. VIF is the inverse of tolerance and vice versa. And that's how we'd go ahead and do that. So the next thing we want to do is, well, this is all great. How do we get this out of Jamovi? So what you can do is just right click, and you can click on analysis if you want specific analysis, or if you click on all, you can click on export. And we can go ahead, I'm going to save this as Jamovi. And I can also go ahead, let's say I wanted for the analysis, I can go ahead and copy this. I can open up a new Word document. And I just go ahead and paste it. So now we have all the Jamovi output that we had before in a Word doc. If I minimize, oops, let me go ahead and minimize all of these things. And I'm going to go ahead, and this is our Jamovi file. And Here is the Jamovi PDF that I exported. It has all that same information from everything we ran. It can also do things like frequencies, factor analysis, a reliability tests, confirmatory factor analysis as well, different linear models, generalized, mixed models. It's a really powerful program, and it's completely free. So I hope this video was helpful. And let me just double check, make sure there's nothing else I want to cover. And yeah, feel free to use this. This is a really nice, lightweight alternative to SPSS, and it can work on any OS as well. So if you're using Linux, if you're using Mac, Windows, Chromebook, this is a good option too. Well, thank you for watching.